Hello everyone, and welcome to episode 6 of the 3D Minecraft tutorial series. This will be a smaller episode than the previous ones, and we'll cover two main things. The first is improving water so it's not just a solid block, and the second is implementing delta time, so our game will run at a constant speed no matter the frame rate. But before that, let's address a very silly bit of design that has plagued our project since the very beginning. See, we have two separate loops for displaying our world, one for casting rays and another for drawing the pixels onto the screen. But there's no reason why we can't do both these things in the same loop. I don't remember exactly why I structured the code like this in the first place, but whatever the reason, I somehow managed to overlook it until now. Duplicate all the code inside the display view block and bring it over next to create camera view. We'll move the things above the display loop to be above the create camera view loop. And you can remove the set eye block. Similarly, the things below the display loop, that is the crosshair display, will move to the end of the create camera view loop. Then, for the things inside the loop, we'll go block by block replacing add to view blocks with blocks from display view. Start by bringing over the goto block. The first input is item I of view, so let's replace it with what that value holds, which is view x. Likewise with view y in the y input. Then you can delete those first two add to view blocks. Then bring over the set pen color and set it to the color variable, and delete the next add to view block. Next, change brightness by the next thing we add to view, which involves brightness mod, this thing here. For the transparency, we've got an if-else, which has two cases. But in the else, we just add 0 to view, which is the default transparency. So we can just delete the else branch and set transparency only to what we add to view in the if part. And that's all the values we add to view. So we just need to bring over the pen down, pen up blocks. And we're done. Look at how much cleaner that looks, and we only needed to loop once. Now we can remove the use of display view in the main loop, and delete the display view custom block entirely. We can also remove the setup of the view list, and of the data per view pixel variable when the flag is clicked, then delete that list and variable. Lovely. Now let's begin our water improvements, starting by making water semi-transparent. Let's use a new value of 2 in the collided variable to represent collision with water. In check collision, let's add, after we get block at, if block equals 8, set collided to 2. Then stop the script so we don't set it back to 1 afterwards. However, we only want to register a water collision if our ray was not in the water before hitting the block. This means we need to keep track of the most recent block our ray has passed through. I'll create a new variable for this called prevBlock, abbreviated from previous. At the top of cast ray, get block at xyz, and set prevBlock to the resulting block variable. Then, inside the loop, after move forward, again set prevBlock to the new block we've moved into. Back in check collision, put an if around our set collided to 2, and check if prevBlock equals 0. In other words, was the ray in air before hitting the water. Keep the stop the script outside the if check so we don't register any other collisions with the water. Now, when we're casting our rays, we'll want to store whether or not we've passed through water, and if so, what color the water pixel was and how far away it was. So let's create two new variables, passed color and passed color dist, both for this sprite. Set passed color to empty at the top of cast array. An empty value for passed color will represent not having passed through water. In move forward, starting with the x direction at the end of the block, and after we find texture color, let's check if collided equals 2, meaning it's a water collision. If it is, we'll set past color to color, and set past color dist to dist, so recording information about the water that we've passed through. Then set collided to empty so we don't stop casting our ray, and finally get block at XYZ to ensure prev block is updated correctly. We'll want to check for a collided of 2 in all 3 directions in the same way, so to avoid duplicating, or rather triplicating this code, let's create a little custom block to hold it. I'll call it water collision. Move the collided equals to statement into the custom block. I'll use the block after we find texture point in all 3 cases of move forward. Now we need to draw these water pixels. So in create camera view, after our existing draw script, and outside the if collided is greater than empty check, let's check if past color is greater than empty. If so, we've passed water. So we'll draw a semi-transparent pixel on top of the one we've already drawn. Start by bringing over the go-to block. Set pen color to past color, and set pen transparency to 20. So the water will always be just a little bit transparent. We'll also want the same fade out effect as with the normal pixels, so duplicate the dist greater than 0.75 times view distance from above, and change the 2 instances of dist to past color dist. We'll want to keep our transparency of 20, so change the set pen transparency to a change pen transparency, and change the 100 to 80, so we get transparencies between 20 and 100, rather than between 20 and 120. Finally, pen down, pen up to draw the pixel. Try this out, and we should now be able to see the blocks below the water. But you'll notice the transparency at the edges is a little wonky. That's because past dist is set to the distance before hitting the water, not after hitting the water. We can fix that just by, in cast ray, moving the set dist block above move forward. Alright, this looks really great. But we still can't go into the water. To fix this, let's start by going into handle player collisions at, and change our if block equals to 0 to if block equals 0 or block equals 8, thus making water no longer solid. Remember, water is block number 8. But we want to have different player movement if we're in water also, so let's make a variable called environment to hold whether we're in air or water. Make a block called find environments. In this block, we'll simply get block at player X, player Y, player Z. Then if block equals 8, set environment to water, else set environment to air. We're going to stick this block right after we move camera in our main loop, and you'll see why we put it here specifically later. We want to move a bit more slowly in the water, so in move player, let's modify what we set change X to. We're actually going to replace both divided by 5 with a multiply by 0.2, which does the same thing on its own. But then we can replace those 0.2 with a 0.2 divided by environment equals water plus 1. Okay, so this looks really cursed, but essentially environment equals water will be 1 in the water and 0 out of the water. Then add 1 so it's 2 in water and 1 otherwise. Then we're dividing by this, so we'll move half the speed in the water. That's not too complicated actually. Now do the same thing for change Z, replacing each divide by 5 with multiply by 0.2 over environment equals water plus 1. Y is more complicated. Get out an if-else, checking if environment equals water. Put all the non-creative mode Y movement scripts up to the change player Y in the else condition. So that's gravity and jumping. In the if condition, gravity will have a lesser effect, so change speed y by negative 0.01. We'll want to add some more drag as well, especially for the case where the player falls into the water from the air and has already built a bunch of downward speed. So add a set speed y to speed y times 0.9. Now check if space key pressed. In the water, we'll just want to move upwards, so set speed y to 0.1. Well, we also want to be able to move downwards, so add an if shift key pressed, set speed y to negative 0.2. You can of course mess around with these numbers as much as you like to get physics that you feel good about. Now get another if-else check for environment equals water, and put the scripts after we handle player collision in the y direction in the else. These are the scripts that handle falling. In the if, just set falling to 0. However, we want to still ensure we set speed y to 0 when hitting a solid block, even if we're in the water. So after the water if-else, check if collided equals 0, and move the set speed y to 0 into that check, just like that. And we can test this now, so try going into the water and see what happens. We're now able to move about and swim. Collision with the bottom seems good. Fantastic! But when we're underwater, it doesn't look very well underwater. The first thing we can do to improve this is to show the water surface above our heads when the player's underwater. What we want is for when our ray goes from the water to air to register a water collision. So, in check collision, add a check for if block equals 0. Then inside that, check if prev block equals 8. So our ray is in the water, but then it's just hit air. So inside, we set collided to 2, and set block to 8, indicating a water collision. Outside of the prev block check, stop this script. And also, now we don't need to check if block is greater than 0 around where we set collided to 1, because we would have stopped the script if block equaled 0. Test this, and now when we go underwater, we can see the surface of the water above our heads. It still doesn't look very watery though, seeing as we still see blue sky. So let's go into backdrops and add a new darker blue backdrop for when we're underwater. I'll use this color, which matches pretty closely that of the water blocks. You can copy it exactly using the hex code if you want. I'll name this backdrop water and the other air. Now back in the game sprite, in Find Environments, let's also get the block at the camera position. If block equals 8, switch backdrop to water, else switch backdrop to air. We can also configure view distance in FOV to be different underwater. So I'll set view distance to 8 and FOV to 36 underwater, and otherwise set view distance to 12 and FOV to 40. Trying this out, going underwater now feels much more watery. You may notice a small jittery effect like this when you go into the water though. This happens because we're moving by a small enough amount that the collision scripts push us farther out of the block than we should be. We can fix this in Handle Player Collision at Point, by changing each of the 0.01 or 1.01 to have a couple extra zeros before the 1. Like so. Oh, that looks much better. And that's water basically done. We're not going to code water physics because the differently shaped stages of water are really hard to code using our raycasting method. However, we can make water flow downwards pretty easily, so we don't end up with odd situations like this one. Make a new custom block called Update Blocks. Stick it in the main loop right after break place blocks. We'll loop through every block in our grid using a standard for loop. So set block index to 1, then repeat grid width times grid height times grid depth. each time changing block index by 1. If our block is water, and the one below it is air, then we want the water to flow downward. Remember, subtracting grid width gets the index of the block below, so check if item block index of grid equals 8, so the block's water, and item block index minus grid width equals 0, so the block below is air. Then replace item block index minus grid width with 8, flowing the water downwards. However, if this block is on the very bottom of the world, this would create a stream of water coming from the top of the world because indices loop around. We don't want that, so we need to check whether the y of the block below is actually less than the y of the block at block index. We can get the y from a block index by moduloing by grid width times grid height, because after growing grid width times grid height blocks, it loops around to a new z value. So check if block index minus grid width mod grid width times grid height is less than block index mod grid width times grid height. Make sure that change block index is outside of this check, or otherwise we would never move on to the next block. Alright, now that looks a bit more normal than what we had going on before. You can also add falling sand in a way very similar to this. Simply duplicate the check for block 8, and check for item block index of grid equals 14. Then replace item block index minus grid width with 14, adding a sand block 1 block down, and then replace item block index of grid with 0, removing the first sand block. And look at that. That looks quite nice. And that means it's now time to code delta time. Yippee! Delta time is the amount of time passed between one frame and the next. Whenever you change a variable, multiply the amount you change by delta time. That way, things will change by the same amount in the same length of time, no matter the frame rate. And the oversimplified rule for when to use delta time is, if you're changing the variable, multiply by delta time, but if you're setting the variable, don't. But first, we need to actually calculate delta time, and to do that, we'll use the built-in timer. Create a new variable, delta time. At the top of the main loop, reset timer. And then at the bottom, set delta time to timer. With this in mind, delta time actually stores the time the previous frame took, but it's close enough. You may remember, though, that we used the timer for the water animations. To keep those working, we'll need to hold an overall timer as well, so create a variable for that, which I'll simply call timer. Set the timer variable to 0 before the main loop. At the end, change timer by delta time. Near the top of Find Texture Color, replace the use of the built-in timer with our new timer variable, like so. Now we need to use delta time. Mostly, we'll need it in the Move Player block, so start there. Where we change player x by change x, let's multiply change x by delta time like we talked about. Now, because time is measured in seconds, this alone would make us move far slower. So increase the 0.2s in both our set change x blocks to 3s. Repeat this process for the z direction at the bottom of the block, changing player z by change z times delta time and replacing the 0.2s with 3s. For the y direction, there's a bunch to change, and it's all a little arbitrary, so just bear with me. In the creative mode movement scripts, change the divided by 5 to a times 3, just like we did with the x and z. And change player y by speed y times delta time. Then, when environment equals water, change speed y by -2 times delta time. When space pressed, set speed y to 1, and when shift pressed, set speed y to -2. For our gravity on land, remove the speed y is greater than 0.5 check from around that. It's not really necessary and can lead to unpredictable speeds. We'll change speed y by -10 times delta time. For the same reason, so jumping is more consistent, switch the falling is less than 3 to a falling equals 0. Inside there, if space pressed, set speed y to 5. Finally, change player y by speed y times delta time. We also need to use delta time with block breaking. So, in break place blocks, replace change mouse by 1 with a change mouse by 20 times delta time. Alright, now if we try that out, everything looks pretty good, and we should be able to move a lot more consistently now. This is built into basically every published video game, so it's a great thing to know a bit about. And with that brings us to the end of this episode, and, at least for the time being, the end of this series. You see, most of the things left for us to do in this project are either really hard or really tedious to code, or both. And furthermore, I don't have much beyond this already coded up. I know there's still a lot of excitement for this series, and I probably will make more 3D Minecraft videos in the future, but for now I'd like to turn my attention to a different type of 3D rendering, which I think is a little more interesting. This type uses triangles to render objects, and can render at high speeds without even using turbo warp. My next tutorial will be on that. I hope to see you there, but until then, have a great rest of your day, and goodbye!